In this video, I'm going to talk about the equation of a line in standard form. So first of all, let's define standard form. The equation of a line in standard form is given by this format. There's a times x, then plus b times y, and that's equal to c, where the following conditions hold true. First of all, first condition is that a, b, and c are integers with no common factors. And there's one more condition. The other condition is that a has to be greater than or equal to 0. So now that we know how standard form is defined, let's ask which of these equations are written in standard form. First equation, 3x minus 2y equals 1. Alright, so we can see this takes the form ax plus by equals c, with a is 3, b is negative 2, and c is 1. So we just need to check these two conditions. First of all, are a, b, and c integers? Well, yeah, 3, negative 2, and 1 are integers. And do they have no common factors? Yeah, there's nothing that goes into all of 3, negative 2, and 1. Okay, so lastly, is a greater than or equal to 0? Well, a is 3, and 3 is greater than or equal to 0, so yeah, this is in standard form. Now how about this next equation, 2x plus 8y equals 4? So again, this is an ax plus by equals c form. A, b, and c are integers. Do they have no common factors? Well, all of these numbers are even. 2, 8, and 4 are all divisible by 2, so they all have a factor of 2. So no, they share a common factor. Therefore, this is not standard form. Okay, now how about this one? X plus 4y equals 2. So a is 1 here, 1x, and then we see that b is 4, c is 2. So a, b, and c are integers, definitely, 1, 4, and 2. Do they have no common factors? Yeah, 1, 4, and 2 don't share any common factors. So good, this is in standard form. Alright, how about negative x plus y equals 4? A is negative 1, b is 1, and c is 4. So these are all integers, that's good. Do they have any common factors? Negative 1, 1, and 4? No, they don't. Is a greater than or equal to 0? No, a is negative 1, a is negative, which means that this is not a good standard form, because a is not greater than or equal to 0. Okay, how about the next one? X minus y equals negative 4. So a is 1, b is negative 1, c is negative 4. These are all integers, they have no common factors, and a is 1, which is greater than or equal to 0. So yeah, this is good. Now how about the next one? Half x plus a sixth y equals 1. Well, right off the bat, we can tell that these are fractions here. These aren't integers, a half and a sixth. And there's the criterion that a, b, and c have to be integers. So no, this can't be standard form. Alright, last one. 3x plus 1y equals 6. A is 3, b is 1, c is 6. These are all integers, they don't share any common factors. A, which is 3, is greater than or equal to 0. So yeah, so this is a good standard form equation. Alright, next problem. Find the slope, y-intercept, and x-intercept of the line 3x minus 2y equals 12. Now, to find the slope and y-intercept in particular, that's always easiest to find when we have the line in slope-intercept form. That just tells us the slope and intercept very explicitly. We just have y equals mx plus b, where m is the slope and b is the y-intercept. So why don't we take this equation and rearrange it into slope-intercept form. Alright. So 3x minus 2y equals 12. We want to move it into slope-intercept form by performing algebraic operations to it. So why don't we get rid of this 3x first, subtract 3x from both sides. That way we can just get y on the left-hand side. So this will cancel here, and we just have negative 2y is equal to negative 3x plus 12. Now we can just divide by negative 2 on both sides, and that cancels the negative 2 that's on the y. We just have y equals negative 3 over negative 2. Negatives cancel out, and we just have 3 over 2. That's multiplying x. and then plus 12 over negative 2. 12 divided by negative 2 is just negative 6, so minus 6. So there we have it. We can see that the slope is equal to 3 over 2, and the y-intercept is equal to negative 6, just from the slope-intercept form. Now let's think about the x-intercept. So first of all, remember the x-intercept is just the point that goes some x-coordinate and then the y-coordinate is 0. Now the x-intercept isn't obvious from slope-intercept form. We'd actually have to plug in 0 for y and solve for x. But it's actually easier to do that in standard form as it is because that doesn't have any fractions. So why don't we just start out with that standard form. 3x minus 2y equals 12. And we'll plug in 0 for y and solve for what x is. So 3x minus 2 times 0 equals 12. So 3x minus 0, or just 3x alone, is equal to 12. And then we divide by 3. Divide by 3 cancels that out. We just get x equals 4. So there is our x-intercept. The x-intercept is equal to 4. Alright, next problem. Convert the following equation to standard form. Y equals 5 over 2x minus 3. Now remember, standard form takes the form ax plus by equals c, where a, b, and c are integers with no common factors, and a is greater than or equal to 0. So we want to take this slope-intercept form as it is right now to solve for y, and convert it into standard form. So why don't we do that over here? Y equals 5 over 2 x minus 3. First step, we need a, b, and c to be integers. So why don't we get rid of this fraction, 5 over 2? We can do that by just multiplying by the denominator on both sides of the equation. So times 2 on both sides, times 2, and the result of that, we get 2y is equal to 5 halves times 2 just gives us 5, so 5x, and then minus 3 times 2 is 6. Alright, so now we want x and y on the same side of the equation. So why don't we go ahead and subtract 5x from both sides. Minus 5x minus 5x, and the result there we get negative 5x plus 2y is equal to negative 6. These cancel out. Alright, now the only remaining thing is that there's a negative on the x, and we need a here. We need the coefficient on the x to be greater than or equal to 0. So why don't we multiply this entire equation by negative 1 times negative 1 on both sides, and then that'll convert that negative 5 to a positive 5, positive 5x, and then minus 2y is equal to negative 6 times negative 1, which is 6. And there we go. There is our standard form equation. 5, negative 2, and 6 are integers with no common factors, and 5 is greater than or equal to 0. Now the next question is to find the equation of a line having slope 3 and passing through the point 1, 1 in standard form. Now when dealing with slopes and particular points, it's always easiest to use slope-intercept form, and we saw previously that we can convert from slope-intercept form to standard form. So why don't we start out by first finding the slope-intercept form. So that's what we'll do first. We'll first find y equals mx plus b. Alright, so we're told that the slope is 3. So why don't we stick in 3 for m, y equals 3x plus b, and passing through the point 1, 1. So we need to fit this line, we need to fit the b parameter here to get the point 1, 1 to satisfy this equation. So we'll just go ahead and plug in that point into here, x and y both 1, so 1 equals 3 times 1 plus b, so 1 equals 3 plus b, subtract 3 from both sides, and we get 1 minus 3 is negative 2. That cancels there, and we're just left with negative 2 equals b. Alright, so our final slope-intercept form equation then is y equals 3x minus 2. Alright, but we're not done yet. We still have to convert to standard form. And let's do that over here. Step 2, convert to standard form. So we'll take that slope-intercept form and use that as a starting point for converting to standard form. We've got y equals 3x minus 2. And now let's get x and y on the same side. So let's subtract that 3x over to the other side, minus 3x on both sides. And then we just have minus 3x, then plus y is equal to negative 2. Now remember, with standard form, we need the coefficient on the x to be non-negative. So we need to get that negative off of the 3. And we can do that by multiplying by negative 1 on both sides, times negative 1. And then we have, well, that just flips the sign on this negative 3, so it becomes positive 3. Also flips the sign on the y, so minus y is equal to, flip the sign on the negative 2, get positive 2. And there we go. 3, negative 1, and 2. All the coefficients are integers. They don't have any common factors, and the leading coefficient here on the x is greater than or equal to 0. So there we go. There is our standard form equation. Here's our final problem. We want to find the equation of the line passing through the points 8, 5 and 8, 2. We want to put that equation in standard form. So again, when we're dealing with lines passing through particular points, it's always easiest to start with slope-intercept form. So that's what we'll begin with again. First step, slope-intercept form. Alright, so for slope-intercept form, first thing, well, here's our template. Our template is y equals mx plus b. And we need m, the slope, b, the intercept. Why don't we compute the slope first, because we have 2 points, so we can go ahead and compute the slope between them. So m equals the change in y, so take 5 minus 2, over the change in x, so take 8 minus 8. And the result there, 5 minus 2 is 3, 8 minus 8 is 0. We get 3 over 0, and that's undefined. Which means our line is a vertical line. So that's the one exception to this slope-intercept form template. Vertical lines always just have x equals to something. And we can tell from both of our points the x-coordinate is 8 in both of them. So x is equal to 8. That's our slope-intercept form. Alright, next step is to put this in standard form. Alright, so we take our slope-intercept form x equals 8, bring that up to standard form, and that'll be our starting point, x equals 8. And actually, this is already in standard form. The coefficient on the x here is 1, which is greater than or equal to 0. The coefficient on the y is actually 0 because y doesn't appear, so it's like a 0y. And then we've got 8, so 1, 0, and 8, these are all integers without any common factors. And the coefficient on the x, 1, that's greater than or equal to 0, so yeah, it perfectly satisfies our definition of standard form. Great, so now we know how to work with the equation of a line in standard form. And in the future, we'll learn more things about lines, including how to tell when two lines are parallel or perpendicular.